video, but if you are, then what I'm going to talk about next is if you want to make an animation that kind of lasts forever, that keeps going instead of having a start time and an end time. This is usually the case when people want to make like something spin, like rotate, or they want to make something move, like just in a straight line forever, or in some kind of constant pattern. So I'm going to go ahead and X this script out, and we're going to work on how we could do something like that in just a second. So let me get, I'll just put that in here, and there we go. Okay, so what I'm talking about is like if you just want to make something, I already went over this, spin or move, basically do the same thing over and over again, but in a smooth animated way. This is actually a lot less to type, a lot less to code, which is good. So it's still going to be based on time, so I'm still going to get run service. Get service, run service. That is not what I typed. Run service. Get part. So the way that we're going to do this is kind of like, it's kind of intuitive actually. What we're doing is, let's say that I want to move this part at a certain speed. When you think speed, you think distance per unit time. So what we're going to do is first, we're going to make the loop for our animation. And next, well, we may as well get the weight out of here, out of the way here. Next we're going to move it forward, and we're going to want to give it a certain speed. So part.cframe, part.cframe times cframe.new. Another thing to note here, what we're doing now is we're actually adding on to the part's previous property here. So we're taking the part's old C-frame and we're basically changing it. We're adding a new C-frame. We didn't do this in the previous example because our previous example had a very defined, this is our start value and this is our end value. So in that case, we weren't actually adding something. We were just constantly calculating a new value and then updating the transparency with that new value. In this case, we're actually going to be kind of adding something to our property here. So we'll change it 0 in the x direction. We'll just move it along the z-axis. So the way that we're going to do this is related to what we just did, and I'll reference that. It's going to be similar to this. And trying to think of a way to explain it. Basically, we're going to take our wait time, so this here, and that's going to be part of our calculation. The reason it's going to be part of our calculation is because we still want our increment to be based on time, just like it was in our previous example. But since we don't have like a defined start time and end time of our animation, then the difference in our time is only given to us by what our wait returns. So that's going to be our increment. So we're going to take that little unit of time and we're going to divide that by what we want the duration of our animation to be every cycle of the loop. So let's say I want this this part to move forward 5 studs every second. And the reason I say studs, which are these things here, this is like the basic unit of distance in Roblox, is because that's what these numbers represent, studs. So 1 in the x direction is 1 stud. So I'm going to divide this by how long how many seconds I want this part to take to move some amount of studs. So I want this part to move, well, like I said, this is our rate of time, so this is per second. So we're going to move it some number of studs per second. Since this is per second, this is a percentage of a second. Now we're going to multiply it by how many studs we want this to move in that 1 second. So we're going to then multiply this by what we want our distance per unit time to be. So, like I said, 5 studs per second. And we don't have to add a wait anywhere else in this loop because we've already used it here. So that still counts. So if I run this script, we should see that nothing happens. What went wrong here? Oh, did I disable? I might have activated the wrong script. There we go. Okay. So, it's kind of hard to tell, but you can kind of make out that this is moving around 5 studs per second, or as close to 5 studs per second as computationally possible. So let's disable that. If I wanted this to move faster, by the way, you might want to always keep this value right here to be 1. You could change it. I could say that I want this to move 5 studs every 2 seconds to make it slower, but honestly, I wouldn't really do that just because of, well, how we use rates of change in real life. You wouldn't say that you go 10 miles per 2 hours. You would say you go 10 miles per hour. So you would usually want to keep your time in terms of unit seconds, and then only change your stud values here. So 1 stud per 1 second would be this right here. Just like that. Cool. Trying to think if there's anything else that I want to explain here. I think that's it. I guess I could give an example of rotation since that's a popular one. So if I wanted this part to just kind of rotate forever in a smooth kind of way, then what I could do is say part is here, part is sometimes. We're just going to change the angles, so we're going to use cframe.angles. And angles are in terms of radians, so we're going to say, what should we do here? Okay, so 1 full rotation is 2 pi radians. So we want to do 1 full rotation, 2 times math.pi. 1 full rotation in, let's see. This is going to be a little bit different. This one you might not want to use, like, just unit seconds for, because 1 rotation in 1 second is pretty fast. Let's say 1 rotation in 2 seconds. Okay, so this is our full rotation. We're gonna multiply this by run service heartbeat wait, divide that by our time, which is 2 seconds, and then times 2 pi. So it might be a little hard to see here because we're using 2 pi as a full rotation. Basically, just, you know what, I'll put it in parentheses to make it a little clearer. This is our rate of time, basically. This is happening every 2 seconds. And we're doing a full rotation, which is 2 pi radians, in that 2 seconds. So, just bring that together again. And actually, well, never mind. I was going to say you could just change this to be 4, but just to keep it readable, we'll just keep it like that. Alright, so if I enable this, yeah. That actually doesn't seem right. Let's see, a full... Oh, no, that's right, that's right. Yeah, so this is a full rotation. Like, if you can use my mouse for a reference point, this is rotating once fully in about a time period of 2 seconds. So you can see, even a full rotation in 2 seconds is pretty quick. If I did it in 1 second, it'd be even faster. Oh, that part's not anchored? Oops. So, if I did that, now it's even faster. But it's pretty cool. Yeah, I think what I would do is I would change, instead of changing time, I would change maybe... I mean, this is going on forever, so you don't really need to worry about... You don't really need to worry about a full rotation. I guess it just depends how you want to look at it. Do you want to measure it in how long it takes for one rotation, or how many seconds you want it to travel, or to rotate in some number of radians? I'm not sure. That's up to you. But, yeah. That part is... I think that part is done. So, without making this video too much longer, I hope you enjoyed. I hope that I made myself clear. I'm not really used to explaining this kind of stuff in an elegant way. So, if you have any questions, feel free to leave a comment, and I'll try to get back to it. And I hope this helps people on the Discord, and hopefully I can use this video as a reference for later. So, I'll see you guys next time.